Hi. So today we're going to be talking about using algebraic expressions. Sometimes you are missing a number that you need to solve a problem. You can represent a problem like this by writing an algebraic expression in which a variable represents the unknown number. So, in this problem that they give us here, they're telling us Rafe's flight from Los Angeles to New York took 5 hours. He wants to know the average speed of the plane in miles per hour. So we know that it took him 5 hours. We just don't know what the speed of the plane was, which for that's talking about our rate formula. So our rate formula is the rate is equal to distance divided by time. They're telling us that it took 5 hours. So we know that our t is 5 hours. They do not tell us how far it is from Los Angeles to New York. So that's our unknown number or unknown quantity. So we're letting d represent the distance traveled in units of miles. D is equal to distance in miles. So then when we put together, we'll have miles per hour. So they're showing you use an algebraic expression for the average speed. So if we plug our t and our d into our formula, we'll find out that our rate or our speed is equal to, we still don't know what the distance is, so we're going to use d, our variable, over 5. And if we want to put in our units, it's going to be d miles, because remember it's distance in miles, over 5 hours. So that's what they're showing over here. So that is going to be our formula, except we're missing our miles. We'll see in the second part of this question, they're telling us that he looked up the distance from Los Angeles to New York on the internet and finds the distance is 2,460 miles. So now that gives us our missing information. So we have to use this to find the average speed. We already had our expression, which was d divided by 5 to find out our speed. But now we know that d is 2,460. So we can say that since d, this was part A, this is part B, d is equal to 2,460. So then what that's going to do for us is we can actually figure this out. So because now that we know that our r is equal to d miles over 5 hours, this is going to give us 2,460 miles in 5 hours. Then all we have to do is divide both our top and bottom by 5 to get to 1 hour. So if we divide both our top and bottom by 5, we can plug that in, and we'll see that our 2,460 divided by 5 is going to end up giving us 492 miles every 1 hour. So that's going to be our speed. The plane's average speed was 492 miles per hour. So that's for the first question on our page 271. If we take a look in the problem on the previous page, the variable represented a single value, the distance in miles between Los Angeles and New York. In other situations, a variable may represent any number in a particular set of numbers, such as a set of positive numbers. So, with this example, they're telling us Joanna makes and sells candles online. She charges $7 per candle, and shipping is $5 per order. Write an expression that Joanna can use to find the total cost for any candle order. So what they're doing is they're letting N represent the number of candles a customer buys, where N is a whole number greater than 0. Because when you order a candle, you're going to order at least one candle. You're not going to order negative candles. So what they're saying is let N equal the number of candles bought where N has to be a whole number. You can't buy half of candles greater than 0. This symbol is an inequality sign, which means greater. Technically greater than. Okay. So they're telling us that each candle is $7, and shipping for each order is going to be $5. So you can buy multiple candles per order, though if you're getting it shipped to the same house, you'd only order it once, which makes for each order the $5 charge a flat fee. Our variable charge, or the charge that's going to happen over and over and over again, is our $7 per candle. So our expression that we can write for the price per order is going to be $7 times the amount of candles that a person buys plus the shipping for their order. And that's what they're saying over here. The cost per order equals the charge per candle, which is our $7, times the number of candles bought. We don't know that. That's why we're letting N equal it, plus the shipping charge. So an expression for the total cost of our candle is our 7N plus 5. In March, one of Joanna's customers placed an order for 4 candles. In May, the same customer placed an order for 6 candles. What was the total charge for both orders? So they're saying total charge for both orders. So we have to find out how much the customer was charged in March, how much the customer was charged in May, and then add the two together. That's what's happening over here. So, for B, we need to use the expression that we came up with. In March, the customer ordered 4 candles. In May, the customer ordered 6 candles. So we're using the same expression for both March and May. It's just we're using different numbers for n in March and May. So in March, we have 7n plus 5, where n is 4. 7 times 4 plus 5. That's going to give us 7 times 4 is 28. Plus 5 is 33. So in March, the customer paid $33. In May, we still have that same expression, 7n plus 5. Now our n is equal to 6. Seven times 6 is going to give us 42. Plus 5 is 47. So in March, the customer paid $33. In May, the customer paid $47. So if we want the total for both orders, we have to add March and May together. So we have March plus May. Our March was 33. Our May was 47. So now we add it together, and we're going to find out that together in March and May combined, the customer paid $80. So the total charge for both orders was $80. This is a little bit about using our expressions. Here on our next page, page 273, they're giving us more questions where we have to create expressions and then use it. So, here they're saying Louisa read that the highest elevation was Mount Everest. Mount Everest is 8,848 meters. She wants to know how much higher Mount Everest is than Mount Rainier. We're using this information for 1 and 2. So we don't know how high Mount Rainier is, so we have to use that as a variable. And then we want to know how much higher Everest is than Rainier. So we're going to have to subtract Everest heights and Rainier's height. So you can choose a variable for Mount Rainier's, and then you're going to use it to try to figure out how much taller Mount Everest is than Mount Rainier. Write an expression to represent the difference in heights of the two mountains. Tell what the variable in your expression represents. In part 2, this is just like part B that we've talked about before, they're telling you that when Louisa researches the highest elevation of Mount Rainier, she finds that it's 4,392 meters. Use your expression to find the difference in the mountain's heights. So before we didn't know that information, so we just had to write an expression. Now they're telling you that information, and you're going to plug it into your expression and solve or evaluate. Here, they're saying a muffin recipe calls for 3 times as much flour as sugar. So what that means is for every 1 cup of sugar we're using, you have to use 3 cups of flour. So they're telling you, write an expression that can be used to find the amount of flour needed for a given amount of sugar. Tell what the variable in your expression represents. So we don't know how much sugar or flour we're using, but the amount of flour we're using depends on the amount of sugar we're using. As I said, if we use 1 cup of sugar, that means we have to use 3 cups of flour. If we use 2 cups of sugar, that means we have to use 6 cups of flour. Basically what's happening is you're multiplying the amount of cups of sugar you're using by 3. So they're asking you to write an expression for that. Then here they're saying, use your expression to find out the amount of flour needed when 3/4 cup of sugar is used. Remember, all we have to do to find out the amount of flour is multiply the amount of sugar we're using by 3. Is the value of the variable in your expression restricted to a particular set of numbers? Explain. What they're asking here is, when we were talking about the candles, we said our candles had to be whole numbers greater than 0, because you can't buy negative amount of candles, and you can't buy half of a candle, you can't buy 2.5 candles. They're asking here, do we have to only be restricted to whole numbers, or can we use rational numbers? Can we use half of a cup of sugar? Can we use 2/3 cup of sugar? Or do we only have to use 1 cup, 2 cups, 3 cups? That's what they're asking there. So then over here, 6 and 7, they're asking you to write an algebraic expression for each word expression. Then evaluate the expression for these values of the variable. Half times 4 and 6.5. Oh, so basically what they're saying here is write your expression and then plug in a half for p, plug in 4 for p, and plug in 6.5 for p. Write your expression over here, and then plug in 1/2 for x in this case, 4 for x, and 6.5 for x. So that's the work that is expected to be done. If you have any questions, please let me know. I'm going to be doing Google Meets for 6th grade at 9 a.m. each school day. So if you have any questions, please let me know, and thank you.